To determine if the cable is large enough, we need to calculate the voltage drop in the cable and compare it to the allowable voltage drop. The voltage drop calculation is as follows: voltage drop equals cable length multiplied by load current multiplied by resistance per foot, then divided by 1000. In this scenario, the cable length is 510 feet, the load current is 150 amps. The resistance per foot can be found using the cable specification sheet. For 4/0 Teck cable, the resistance per foot is approximately 0.7 ohms. So, the voltage drop equals 510 feet multiplied by 150 amps multiplied by 0.7 ohms, then divided by 1000. Voltage drop equals 5.67 volts. The allowable voltage drop for residential services is typically 5%. For a 120/240 volt service, the maximum allowable voltage drop is 6 volts. In this case, the calculated voltage drop of 5.67 volts is less than the allowable voltage drop of 6 volts. Therefore, the 4/03 Teck cable is large enough for the 120/240 volt service given the stated parameters. Now let's consider what to do if the voltage drop exceeds the allowable voltage drop. There are a few options to rectify the situation. Firstly, consider increasing the cable size. Installing a larger cable with the lower resistance per foot will reduce the voltage drop. Secondly, consider reducing the load. Decreasing the electrical load in the service will reduce the current flowing through the cable, which will in turn reduce the voltage drop. Thirdly, consider adding a voltage regulator. A voltage regulator can be installed to maintain a constant voltage at the load, regardless of the voltage drop in the cable. The most cost-effective option will depend on the specific circumstances of the project. Let's delve a little deeper into each of these options. When considering increasing the cable size, it's important to understand the relationship between cable size and resistance. Larger cables have a greater cross-sectional area, which allows electrons to flow more easily, resulting in lower resistance. The lower resistance directly translates to a lower voltage drop for a given current. When selecting a larger cable, consult the National Electrical Code, specifically Table 310.15b16 or a similar table for your local electrical code, to ensure that the cable is appropriately sized for the load current and the installation conditions. The table will provide ampacity ratings for different cable sizes and insulation types. Be sure to consider dirting factors for ambient temperature and the number of conductors in a raceway or cable. Remember that increasing the cable size may also require larger conduit, fittings, and termination equipment, which can add to the overall cost. When evaluating the option of reducing the load, consider which electrical loads are essential and which can be reduced or eliminated. This might involve replacing high wattage appliances with more energy efficient models, such as switching from incandescent light bulbs to LED lighting. It could also involve shifting the use of certain appliances to off-peak hours, when the overall load on the service is lower. For example, running a clothes dryer or dishwasher during the day instead of in the evening, when other appliances are in use, can help reduce the peak load. Analyze the electrical consumption patterns of the house to identify areas where energy savings can be achieved without significantly impacting the resident's lifestyle. A home energy audit can be a valuable tool in this process. When considering the addition of a voltage regulator, it's important to understand how these devices work and their limitations. A voltage regulator is an electronic device that maintains a constant output voltage regardless of variations in the input voltage or load current. It does this by actively adjusting the voltage supplied to the load, compensating for any voltage drop in the cable. Voltage regulators are available in various sizes and configurations, and it's essential to select one that is appropriately rated for the load current and the voltage range of the service. Voltage regulators can be relatively expensive, and they also consume some power themselves, which can add to the overall operating cost. However, they can be a very effective solution in situations where it's not practical or cost-effective to increase the cable size or reduce the load. When selecting a voltage regulator, consider the following factors: the voltage regulation accuracy, the response time, the efficiency, and the reliability. The voltage regulation accuracy specifies how closely the output voltage is maintained at the desired level. The response time indicates how quickly the regulator can respond to changes in the input voltage or load current. The efficiency is the ratio of the output power to the input power, and the reliability is a measure of the regulator's long-term stability and performance. It's also important to consider the installation requirements for the voltage regulator. Some regulators may require special wiring or grounding, and it's essential to follow the manufacturer's instructions carefully. Before making a decision on which option to pursue, it's helpful to perform a cost-benefit analysis of each alternative. This involves estimating the cost of each option, including materials, labor, and any ongoing operating costs, and then comparing these costs to the benefits that each option provides, such as reduced voltage drop, improved energy efficiency, and increased reliability. Consider the long-term implications of each decision. For example, while increasing the cable size may be more expensive upfront, it can provide a more robust and reliable solution in the long run, reducing the likelihood of future problems. Reducing the load may require a change in lifestyle, but it can also lead to significant energy savings over time. Adding a voltage regulator may be the most cost-effective option in the short term, but it may require ongoing maintenance and may not be as reliable as other solutions. When making your decision, consult with a qualified electrician or electrical engineer to ensure that the solution is safe, effective, and compliant with all applicable codes and regulations. They can provide valuable insights based on their experience and expertise, and they can help you avoid costly mistakes. Also, consider the impact of your decision on the overall electrical system of the house. Make sure that the solution is compatible with the existing wiring and equipment, and that it does not create any new problems or hazards. Pay attention to the details of the installation. Ensure that all connections are properly made and that all equipment is securely mounted. Use high-quality materials and components, and follow all manufacturer's instructions carefully. A well-executed installation will provide years of reliable service. In summary, determining the appropriate cable size and addressing voltage drop issues requires a thorough understanding of electrical principles, careful calculations, and a consideration of various factors, including the load current, cable length, resistance per foot, allowable voltage drop, and the specific circumstances of the project. By following these steps and consulting with qualified professionals, you can ensure that the electrical system is safe, efficient, and reliable. In this specific scenario, with a 4/03 Teck cable, a 120/240 volt service, a 150 amps load, and a cable length of 510 feet, the calculated voltage drop of 5.67 volts is less than the allowable voltage drop of 6 volts, indicating that the cable is adequately sized. However, if the voltage drop were to exceed the allowable limit, options such as increasing the cable size, reducing the load, or adding a voltage regulator should be considered, with the most cost-effective option depending on the specific circumstances. Remember to prioritize safety and consult with qualified professionals throughout the process. Let's explore some additional considerations regarding cable sizing and voltage drop. Firstly, it's crucial to accurately determine the load current. Overestimating the load current can lead to oversizing the cable, which increases costs unnecessarily. Underestimating the load current can result in excessive voltage drop and potential overheating of the cable, which can be dangerous. Use accurate load calculations based on the actual appliances and equipment that will be connected to the service. Consult the nameplate ratings of appliances and equipment to determine their power consumption and factor in any diversity factors that may apply. A diversity factor is a ratio that accounts for the fact that not all appliances and equipment will be operating at their maximum power consumption simultaneously. Secondly, consider the impact of future load growth. If you anticipate that the electrical load on the service will increase in the future, it's wise to size the cable accordingly. This can avoid the need to replace the cable later on, which can be a costly and disruptive process. Thirdly, pay attention to the installation conditions. The ampacity of a cable is affected by the ambient temperature and the number of conductors in a raceway or cable. Higher ambient temperatures and more conductors in a raceway or cable will reduce the ampacity of the cable. Consult the National Electrical Code, specifically Table 310.15b16 and the associated dirting factors to ensure that the cable is appropriately sized for the installation conditions. Fourthly, consider the type of cable. Different types of cables have different resistance values. For example, copper cables have a lower resistance than aluminum cables. Use the appropriate resistance value for the type of cable being used in the voltage drop calculation. The resistance per foot of the cable can be obtained from the cable manufacturer's specifications or from electrical handbooks. Fifthly, consider the length of the cable run. Longer cable runs will result in greater voltage drop. Minimize the length of the cable run whenever possible to reduce voltage drop. This can be achieved by locating the service panel closer to the load center or by using a different wiring configuration. Sixthly, consider the voltage drop requirements of sensitive equipment. Some electronic equipment is very sensitive to voltage variations and may not operate properly if the voltage drops too low. Check the manufacturer's specifications for the equipment to determine its voltage drop requirements. If the voltage drop exceeds the allowable limit for the equipment, take steps to reduce the voltage drop, such as increasing the cable size or adding a voltage regulator. Seventhly, consider the costs of different options. When evaluating different solutions to voltage drop problems, consider the cost of each option, including materials, labor, and any ongoing operating costs. Choose the option that provides the best balance between cost and performance. Eighthly, consider the environmental impact of different options. Some solutions, such as using larger cables, may require more resources and have a greater environmental impact than other solutions, such as reducing the load. Choose the option that minimizes the environmental impact while still meeting the electrical requirements. Ninthly, consider the aesthetics of different options. Some solutions, such as adding a voltage regulator, may be more visually appealing than other solutions, such as using larger cables. Choose the option that is most aesthetically pleasing while still meeting the electrical requirements. Tenthly, consider the long-term reliability of different options. Some solutions, such as using larger cables, may be more reliable in the long term than other solutions, such as adding a voltage regulator. Choose the option that is most likely to provide reliable service for many years to come. Let's also discuss the importance of proper grounding and bonding. Grounding and bonding are essential for electrical safety. A properly grounded and bonded electrical system provides a lower impedance path for fault current to return to the source, which helps to protect against electric shock and fire hazards. Make sure that the grounding and bonding system is installed in accordance with the National Electrical Code and any local codes and regulations. Use the correct size grounding and bonding conductors, and ensure that all connections are tight and secure. Regularly inspect the grounding and bonding system to ensure that it is in good condition. It is important to have surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other transient events. Voltage surges can damage or destroy sensitive electronic equipment, such as computers, televisions, and appliances. Install SPD at the service entrance and at branch circuits to protect against voltage surges. Choose SPD that are appropriately rated for the voltage and current levels of the electrical system. Regularly inspect the SPD to ensure that they are in good condition. In addition, ensure arc fault circuit interrupters, or RFCs, are used. RFCs are circuit breakers that protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. RFCs detect arc faults and quickly shut off the power to the circuit, preventing a fire from starting. Install RFCs in all branch circuits that serve living areas such as bedrooms, living rooms, and family rooms. Regularly test the RFCs to ensure that they are working properly. Ground fault circuit interrupters, or GFCIs, protect against ground faults. Ground faults are dangerous electrical conditions that can cause electric shock. GFCIs detect ground faults and quickly shut off the power to the circuit, preventing electric shock. Install GFCIs in all branch circuits that serve wet locations, such as bathrooms, kitchens, and outdoor areas. Regularly test the GFCIs to ensure that they are working properly. Remember to always work safely. Working with electricity can be dangerous. Always follow safe work practices when working with electricity. De-energize the circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment such as gloves and safety glasses. Never work alone. If you are not comfortable working with electricity, hire a qualified electrician. Electrical safety is paramount. Working with electricity can be dangerous, so it's crucial to follow safety precautions and best practices. Before starting any electrical work, always de-energize the circuit by turning off the corresponding circuit breaker or fuse at the service panel. Verify that the circuit is de-energized using a voltage tester before touching any wires or components. Use insulated tools and equipment that are specifically designed for electrical work. Wear appropriate personal protective equipment such as insulated gloves, safety glasses, and non-conductive footwear. Never work in wet or damp conditions, as water can conduct electricity and increase the risk of electric shock. Avoid working alone, especially if you are not experienced in electrical work. Have someone nearby who can assist you in case of an emergency. If you are not comfortable or confident in your ability to perform electrical work safely, hire a qualified electrician to do the job. They have the knowledge, skills, and experience to handle electrical tasks safely and effectively. Regularly inspect electrical cords and appliances for damage, such as frayed wires or cracked insulation. Replace any damaged cords or appliances immediately. Avoid overloading electrical circuits by plugging too many devices into a single outlet or extension cord. This can cause the circuit breaker to trip or, in more severe cases, lead to overheating and fire. Use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. These devices can help prevent damage to computers, televisions, and other appliances. Keep electrical panels and outlets clear of obstructions such as furniture or clutter. This ensures that they are easily accessible in case of an emergency. Teach children about electrical safety and the dangers of playing with electrical outlets, cords, and appliances. Consider child-proofing outlets with covers or protectors to prevent accidental shocks. In summary, the safe and effective operation of an electrical system relies on a combination of careful planning, accurate calculations, proper installation, and adherence to safety precautions. By following these guidelines and consulting with qualified professionals when necessary, you can ensure that your electrical system is safe, reliable, and meets your needs for years to come.